Okay, so I've commented here on the idea of increased rigor in the argument on number 47. Number 48 could also be done with similar rigor. But both are well done, so. Let's see, what else do we have here? Oh yeah, this thing about the calculator, I ended up not having time, or at least not being able to stay awake long enough to redo the calculations. But there's nothing wrong with the approach. You just get a big old messy polynomial. You then have to evaluate at 1. So I'm not sure I see an error in any of the polynomials. I looked at them fairly closely, but I didn't do the arithmetic with all the fractions. But I don't trust a calculator. So, and it is possible, let's see, we've got a decent common denominator here. Well, it's hard to separate these pages. Okay, you got numbers like 2, 4, 8, 5, 15, 9. Everything's multiples of 2, 3, and 5. So it appears that third power of 2 multiplied by second power of 3 multiplied by 5 would give you a common denominator, just glancing at what I see. And I guess you need a 2. You need another power of 2 to do the 1/2. So that would be what? 2 to the 4th is 16, times 9 is 144, times 5 is 720. It would be a perfectly good common denominator if my quick glance was worth anything. And let's see. Yep, Book's answer gave you 1 over 720. So, and you said the calculator's answer, well, let's go back again. Need to stop doing that. Okay. Well, you got 79 over 360, negative 79 over 360 from the calculator, and that's consistent with the common denominator 720. Okay, anyhow. What else? How'd that get in there? Nice attempt at the figure on number 31. But when I look at the numbers, I really can't spot an error in your calculations. I'm just thinking that when you take a cylinder of radius 1 and cut another cylinder of radius 1, you get a section. Everything you have is within a section of length 2 of that cylinder that you cut with the other. So you're intersecting 2 perpendicular cylinders of radius 1. The volume of a section of length 2 of a cylinder of radius 1 is 2 pi, because the area, cross-sectional area is pi. You multiply by 2, and that's obvious. And that's about 6.28. The integral that you got for the intersection is 16/3, which is 5 1/3, which is within 1/6. It's at least 5/6 of the volume of that section of the cylinder. When you cut the cylinder with this one, it just intuitively seems a little high. But I'm having trouble convincing myself that it would be that high, although everything with your integral looks fine. So, just kind of intuitively wanting to reconcile that. So think that through, maybe even convince me with a good picture. And you've got a nice attempt at the picture. Now I've got cylindrical pieces of pipe, PVC pipe around the lab, and we could actually sketch this thing, but it's more fun to try to do it by thinking it through. had a little note on number 42, why we're using the tangent. Well, that's because of what you use. Okay. First glance, I wanted to use a sine because I was thinking radial. And so ignore that note. Oh yeah. You did a nice job with the volume of a sphere. You essentially used cylindrical coordinates. You might have been thinking in rectangular coordinates, but then went to cylindrical. And I recommend being able to do the volume of a sphere in cylindrical, rectangular, polar, spherical coordinates. It's a good exercise. And basically being able to do a lot of the basic shapes, especially like a rectangular parallelepiped in spherical coordinates. Yeah, that takes a little bit, but I remember, just out of curiosity, wanted to work that out when I took this course. Because I had a lot of time on my hands when I took that course due to some surgery I had this previous semester, and the fact that I was out of sequence in all the courses. Didn't have that many I could take. So I had a lot of time. You don't necessarily have that much time, but you're a lot smarter than I am, so, think it through. Okay. So hopefully I haven't insulted your intelligence too badly with my stupidity. I've done a few things here that seem like they ought to work out a little better, be done a little more elegantly. So take it for what it's worth. It's my review of your homework. I'll send you a copy probably before this is even posted.